Hi everyone, welcome to day 15 of Advent of Code. Be going into the problem blind so you can see my thought process as I work through the solution. Let's get right into it. Day 15, Lens Library. A newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, personal protective equipment required beyond this point. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snout mark and the label Push for Help. No wonder you were loaded into that trebuchet so quickly. You pass through a final set of doors surrounded with even more warning signs, and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you to a book titled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm, Appendix 1A. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range 0 to 255. To run the hash algorithm on a string, start with the current value of 0. Then, for each character in the string starting from the beginning, determine the ASCII code for the current character of the string, increase the current value by the ASCII code you just determined, set the current value to itself multiplied by 17, and set the current value to the remainder of dividing itself by 256. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. Cool. So this just goes through this hash, goes through the algorithm for this test string, but it seems pretty straightforward. The initialization sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore new line characters when parsing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization sequence. For example, you have a list of steps. Okay, so we want to run the hash algorithm on each step and return the sum. Cool. That doesn't seem too hard. So we have one long line here. Okay, yeah, and it's one line. Yeah, comma separated. So let's get into it. Let's change our code a little bit. We don't need a split line it's here. We just have one line. So it's just gonna be line, and then we can change the function signature. Similarly for part 2, just one line. Cool. So we'll have a total. We'll go through each step in a line splitting on comma. And then we'll run the hash algorithm. So we start with value equal to 0. And for char in step, value increases by the ASCII value. I think that's right for the ASCII value. Multiply by 17. And then mod equals 256. And then just increment the total, that value, return the total. It seems super straightforward, but I think that's all we need, right? Yeah, let's just run it, I guess. Not correct. All right, let's run an example. $13.20, which is correct. Okay. I wonder if like the final new line is messing us up. Because here we don't end with a new line. I guess we can call it dot strip. And now we are getting a slightly different value, which I assume this is correct. Just have to wait a couple seconds. Cool, that's correct. That was a very easy part one. All right, part two. Convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes numbered 0 through 255. The boxes are arranged in a line starting from the point where the light enters the facility. The boxes have holes that allow the light to pass from one box to the next all the way down the line. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box is a panel that opens to allow you to insert or remove lenses as necessary. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length from 1 to 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform, either an equals or a dash. If the operation character is a dash, go to the relevant box and remove the lens with a given label if it is present in the box. Then, move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. Cool. If the operation character is an equal sign, it'll be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label marker to mark the lens with the label given in the beginning of the step so that you can find it later. There are two possible situations. If there's already a lens in the box with the same label, replace the old lens with a new lens. Put it in its place, not moving any other lenses. If there's not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. All the boxes are shown. Okay, so like here we put so then the power of each lens is equal to its number times the slot times the focal length. And then you sum those up. Okay, I guess a little bit confused. Let's go back to the start. Each step begins with a label. go to the relevant box. So how do you determine the relevant box? I assume that you determine the relevant box by hashing the input. So I guess let's just put this hash in its own function. And then again, char in string. So we're getting the same value. So what happens when you hash rn? Assume that's how you get the box. You get 0. If you hash this whole thing, you get 30. Okay, so you hash the label to get the box index, I guess. This also box 0. QP should be 1. Okay. Cool. This looks like the label is always 2 characters. So label equals line this. I guess step in line. We can get the label and then the operation. Let's just run this as an example. Rn equals followed by the focal length. So if operation is equal to equal sign, do something otherwise we have the minus. So I think, okay, whoops, this is step. Cool. Step in line dot split. Yeah. And we have the focal length, which is step 3. Okay. Let's just use our wash script. I made a couple changes to this, so it actually works a little bit better now. Or it's just easier to use. It's exactly the same functionality. Okay, I can also talk a little louder right now. Last video was kind of quiet. Okay. So yeah, okay, let's have a data structure to store boxes, just dict, where the key is the box index, and then the value is a list of tuples which have label and then focal length. Cool. Yeah, let's just use a default dict. So this will just be a default dict list. So, yeah, if it's an equal sign, can calculate the box index equal to the hash label, and then okay, so operations equals. We can check. We can see the box labels is equal to boxes box index. And then we want the lens in. Obviously that's going to be empty for now. So if label in box labels, replace the old lens with the new lens. I guess what we can do instead is we can iterate over for box label box focal length in boxes box index if box I guess that we can just maybe it's better if we just mutate all this so this could not be a tuple but a list. Then do for I in range length boxes. No, this is fine. Just wrap this in enumerate. If box label is equal to label, boxes box index, I1 is equal to the is equal to the new focal length. And then we can break, and then else boxes box index dot append this list of label focal length, and then yeah. Okay, so that looks right. Now let's handle the minus operation. then remove it. So we can reuse the same code. And then the index will be I. Cool. So let's just run this in a full example and then look at label operation boxes. Okay, we are getting an error, but let's just see this here. Let's just change this to just bring out the step. Okay, so that works, that works. In one, we're putting QP3. Just right. Which one is giving us an error? So AB5 works. So it's PC minus. So PC goes in box 3. Oh, sorry, this is wrong. Cool. So then this is our final situation. So box 0 has RN1, CM2. 1 empty, 3 has OD7, AB5, PC6. Cool. So it looks like everything's working. Let's clean comment this out. And now we gotta get the return value. So, okay, it's the box index. Okay, cool. So for I guess box index lenses in boxes of values. Let's for focal length in lenses, and then this needs to be new rate. Total plus equals box index plus 1 times the slot. It's going to be the slot times focal length. Return that total. Cast this to an int. What's the problem? This is not values. Items. The solution of 145. That's correct. Let's run it on the full example. Not right. Okay, interesting. Interesting. Yeah, let's debug this. This seems right. So we had 145, which is correct. I wonder why this is getting messed up. So 1, 4, 28, 40, 72. Okay, so the example works totally fine. It's... Do I have some test code in here? What did it tell me? Was it too high or too low? Not that that really matters so much, but too low. Okay, I honestly have no idea what's going on because the example is working perfectly fine. Let's run again on the main input. 515495, is that correct for part 1? To be mostly awesome. 515495. Jeez. Trying to think what I'm missing. Everything seems like it should be working. Last RMZBRV minus. Okay. Oh, okay. This is the problem. Because these labels are not... Okay. Because the labels have length longer than 2. Got it. Can we split on multiple characters? No. Let's just use regular expressions because I feel like it's always good to polish up those skills. Yeah, let's here back to the example. And yeah. So we want to find the and then another capture group that's either equals or minus. And then we have a third that is like this. Cool. Okay, cool. Looks like this is working. Yeah. This is nice. So instead of we can have here this, we want to get the first index of that, then we can unpack label operation focal. It's equal to this. Still get the box index in the same way, and then focal length, to cast that to an integer. Cool. And we still get the correct answer. Now let's run it on the input. Ooh. This can now be removed. Okay. I think this should work. It does. Cool. Yeah, this is pretty straightforward. The only thing that slowed me down a little bit was making this mistake on not understanding the label operation focal length, or the label specifically, what sizes it could be. Yeah, I think this is extremely straightforward, but let's go through the solution. So for part one, all we need to do is go through each step, and hash the value. Where the hash function is super simple. We just go through the characters in the string and apply the steps that they tell you to apply. You increment it by the ASCII value, multiply by 17, and then return the value modulo 256. And yeah, that's that. Then and then the one thing that tripped me up a little bit was that the line includes a new line at the end. And so the final step was containing a new line character. The way we dealt with that was by taking the input and stripping it, so removing that trailing new line. Then for part two, we have to store lenses in boxes. The data structure I chose was a dictionary of lists, where each value in the list is like a tuple with the label and the focal length. Yeah, and so essentially we iterate over the steps again, use this fancy regular expression to get out the label operation focal length from the step. Then if you don't know how the syntax for this, I would just look it up. I'm not going to go through exactly how the regular expression works. Get the box index by hashing the label. Then we just apply the steps that they tell us. If we have the equals operation, we check to see if we have a lens in the box with the same label. If so, we just update the focal length to the new focal length. If we don't have a lens with the same value, the same label in the box, then we just append it. If we have this minus operation, we just check if in the given box we have a lens with that label, and if so, we remove it. Finally, to get the total, we just sum up for each lens the box index plus 1, the slot it's in, which is also indexed at 1, and then the focal length. Then we return that total, and that's it. All right, a little bit easier one today, but glad we were able to breeze through it. Yeah, that was day 15. If you have any questions or comments, leave them below. Thanks for watching, and I'll see you tomorrow for day 16.